Hey guys, this is my video for hopefully clarifying how to do these sorts of problems. This is going to be a problem where we are calculating the limiting and the excess reagent, and then we are calculating how much of something is produced. Okay, we're going to be doing question number 10. This is from page 235. The question asks, you have solid iron 3 oxide and you heat it in the presence of carbon monoxide, and you're going to produce iron metal and carbon dioxide gas. As always, the first thing to do is write a balanced chemical equation, and after that you're going to be doing the calculation for how much iron you're actually producing. Okay, so let's start off then with the balanced chemical equation. This is where nomenclature comes in handy, because obviously you need to know how to do your nomenclature in order to write a balanced chemical equation if all you're giving is the word. So here is your chemical equation. It's Fe2O3 is iron 3 oxide. Carbon monoxide, iron, carbon dioxide. To balance it all out, you're going to need 2 of those, which gives you 4 iron, and that's going to create 6 oxygen, so we need 6 more oxygen from here to get 12, and then 6 times 2 is 12, so there's 12 and 12, and then the 6 and the 6 are balanced. There's our chemical equation. Okay, so in order to solve this, the first thing we need to do is find our limiting reagent. Once we know which one is going to be limiting in this chemical reaction, we then use the limiting reagent to find the mass that we can actually create. Okay, so step number 1, find the limiting reagent. We are told in the question that we have 74.2 kilograms of iron 3 oxide, and we've got 43 kilograms of carbon monoxide. So in step 1, part A, first pick one of them. It doesn't matter which one you pick. I generally pick whatever's first just because it's there and it's first. So I used my known mass of Fe2O3 that I was given. Calculate how much carbon monoxide I could, in theory, react with. Okay, so if I start off with this mass of iron 3 oxide, remember that you've got to convert that to grams in order for your periodic table, which is in grams per mole, to make sense, right? So convert that to number of grams. So I've got 74,200 grams of iron 3 oxide. I then convert that to number of moles of iron oxide that I have. That's what I'm doing here, because remember, your number of moles is your mass divided by your molar mass. My molar mass I calculated off on the side over here as 159.66 grams per mole, because there's 2 iron molecules, 3 oxygen molecules, add them all together to get that. Okay, so I'm doing my mass divided by my molar mass, which means at this point right here, I would have number of moles of Fe2O3. I am then doing a molar conversion. If I have, from my chemical equation, if I have 2 moles of this, I can react with 6 moles of this, or it's a 1-to-3 ratio, 2-to-6 to do it properly, right? So now that's what this step is here. So this is saying if I've got 2 moles of this, I'm reacting with 6 of that. Okay, so I'm converting now from my number of moles of iron 3 oxide to moles of carbon monoxide it could react with. And I end up with the result of 1,394.21 moles of carbon monoxide. So this whole section here is saying if I reacted 74.2 kilograms of iron 3 oxide, I would use 1,394 moles of carbon monoxide. Okay, so that's the first thing that I need to do in part 1. And the second thing I need to do in part 1 is using the carbon monoxide that I was actually given, which is 43 kilograms. I now calculate the number of moles I have available. So we know that I could, if I wanted to, use 1,394.21 moles of carbon monoxide. How many moles do I actually have? Well, same calculation. Number of moles is equal to mass divided by molar mass, right? Remember your triangle. Molar mass, number of moles. Since I'm looking for number of moles, it's mass divided by molar mass. So I've got my mass here. I divide by 28.01, which is the molar mass of carbon monoxide, and it ends up I have 1,535.16 moles of carbon monoxide. So using all of my iron 3 oxide, using it all, I would react with 1,300, almost 1,400 moles of carbon monoxide. I have over 1,500 moles available. So I have more than enough carbon monoxide. The most I would ever use is 1,394 moles, and I have 1,535. So that must mean that the iron is limiting. Okay, so our iron 3 oxide is our limiting reagent in this chemical reaction. So when we're doing part 2, finding the mass of iron we can create, we're going to be using the mass of iron 2 oxide, which is the limiting reagent in this place. So that's what the sentence is saying here. If I used up 74.2 kilograms of iron 3 oxide, I would use up to the maximum amount I would use up is 1,394.21 moles of carbon monoxide. And I have 1,535 moles. Since I have excess carbon monoxide, iron 3 oxide is my limiting reagent. Okay, so that is how to find the limiting reagent. Now that I have that, I can do part 2, which is find the mass of iron I'm creating, using my known mass of iron 3 oxide because it is limiting. And how much iron can I make? Well, I start off with my 74.2 kilograms, my 74,200 grams of iron 3 oxide. I convert that to number of moles of iron 3 oxide, Fe2O3. That's where we're at here. Then, in my chemical reaction up here, if I am using 2 moles of this, I'm creating 4 moles of that. That's why this 2-to-4 ratio is here. So at this point, I'm at my number of moles of Fe2O3. I know that I'm going to be creating double the amount of iron because it's a 2-to-4 ratio, which is a 1-to-2 ratio, right? Which is doubling. So down here, I'm going to multiply by 4 and divide by 2, which is multiplying by 2. It's doubling it, right? So I'm just doubling the amount here because for every 2 moles of this, I'm creating 4 moles of that. So at the end of this, I will be shown how many moles of iron I have. Right? That's what I'm getting at the end of this calculation. Now, if I look at how to find my mass, I do my molar mass times my number of moles. I have my number of moles. I just need to multiply by my molar mass in order to convert that now to mass of iron because I have my number of moles of iron. Multiply by the molar mass of 55.85 grams per mole. And I'm going to get 51,911.18 grams of iron or 51.9 kilograms of iron. Okay. Now, if I go back up to here, let's make sure my units are working out. I've got grams of iron 3 oxide canceling out because it's at the top and the bottom. Moles of iron 3 oxide top, moles of iron 3 on the bottom. They cancel out. Moles of iron, those cancel out. And I'm left with just grams of iron. So the way I have it set up in this line, I know I've done it correctly. And the answer in the textbook also, I think, says that. I would assume so because I didn't do anything wrong. So what this problem then is saying, if I use 74.2 kilograms of iron 3 oxide and 43 kilograms of carbon monoxide, this is going to be limiting, and I will be creating, if I do the reaction, I will make 51.9 kilograms of iron. Okay? That's how to do this. I hope this was useful. I will be posting this, and it started off actually really neat, and then I started adding notes all over the place, and now it's looking a little bit messy. I do apologize for that. I still will post this. I hope it's helpful. I hope this video was helpful. Keep practicing. A lot of you guys are so close to getting it 100%. It's just a matter of doing problems over and over and over and over and over until you finally get there, okay? And we're going to be doing it in class a fair bit to make sure we are all there. So if you do understand it and you're in class, just accept the practice, and sorry if we're doing the same thing over and over again. If you're not there yet, keep using the time in class you have effectively. Okay, that's all, and I hope this was helpful. Take care of yourselves, guys.